Alright, this is the free fall review, and I'll remind you that what you're going to need is your kinematics equations. So you're going to dig those out of your notes, find those. You could go back into Unit 3 in the notes and find them if you need to find them there. I'm just going to, I happen to know them. I have them memorized because I'm a physics teacher. So I'm just going to be writing down the ones that I need when I need them. But you should have attempted this on your own already, and you should do that with your kinematics equations handy. Alright, so number one, a ball is thrown downward with an initial speed of 20 meters per second. I'm going to go ahead and start making my list. Checking it twice. I am going to check it twice, in fact, because you need to check for signs and make sure you get those right. I always take up to be the positive direction, even if everything is happening in the down direction, just for consistency. Ball is thrown downward, so that means its initial velocity here is down. In my experience, students are prone to missing that minus sign right there. And I know since it's a free fall problem, the acceleration is -10. I get that for free, right? For a free fall. Make a well-labeled diagram of the situation. So that just means here's my ball. Its initial velocity is downward, 20 meters per second. That looks good. Nothing else really to diagram. Make a list of given quantities. Oop, look at that. I made my list up here just to make it here. Right here. What's the acceleration of the ball? It's -10 meters per second squared. Calculate the displacement during the first 4 seconds. So that would be putting a 4 here. And if we want the displacement, that is going to be this equation right here. So delta y is equal to 1/2 times -10 times 4 squared plus -20 times 4. Now I don't have to do any algebra here. That's all on this side, and that's what I'm trying to solve for. So my calculator. So 1/2 of -10 is -5. I bet you knew that. Times 4 squared minus another 80. So the displacement is -160 meters. What does the negative sign mean there? It means that it's ending lower than where it started. It means the displacement is down, and that makes sense because it was thrown downward. Calculate the time required, so not using that 4 anymore, to reach a speed of 50. So that's, we don't know the time now, we know that, and we want to know the time required to reach a speed of 50. Now, if you think about what's going on here, it's never going to reach a velocity of positive 50 because it's starting with a velocity of -20 rather, and then this is what's happening to the velocity every second that goes by, -10, -10, -10. So it's never going to get to positive 50. It is going to get to -50. You can set up the equation you want, but maybe you can see that you're going to have to subtract 10, subtract 10, subtract 10. You're going to have to do it 3 times. So 3 seconds. If you wanted to set up the equation, it would be this one. That's your -20. This would be -50. There's your -10. Solve for that, and you get 3. Calculate the time required to fall by 300 meters. And then there's this hint here about factoring the quadratic and using the quadratic formula. We're not going to do that. I'm going to show you a way to do it with the calculator. That will be important because this whole factor the quadratic thing, things have to be set up very, very nicely for you to be able to factor something, and that is usually not going to be possible. So we don't want to rely on that method. So So delta y equals 1/2 at squared t. So time required to fall, then we're going down 300. So that's negative 300 there. This is minus 5 t squared minus 20 t. Okay, so this is what we're going to do. The method that we are going to use is a graphing method. We are going to graph this. Now, before I graph this, I need everything to be on one side. So if I move this, add it to the other side, like so. And then I'm going to go ahead and put this in. Now, I'm just going to put in x's in place of the t's, because that's what my calculator likes. Yours too. Okay. Now, before I hit graph, I'm going to go to my window and think here for a minute. How long is this going to take? The x values here, that's what we're looking for. So that's going to happen sometime between time 0 and time, I don't know, how long do you think is it going to take to fall 300 meters? We could guess. I'm just going to make that 10. Definitely 10 seconds should be plenty of time for that to happen. And then here, whatever your y-min and your y-max, it really does not matter that much what those numbers are, because all we need is to see where it crosses the axis. So those were set at negative 3 and 3. I'm just going to leave it like that. And then I'm going to graph. We should see that thing blasting across the axis right there. Now this is 0 and 10, so what I need to do is I'm going to do second calculate, looking for the 0, that's where it crosses the axis. Right, we have it set equal to 0. And you can play that little game with the cursor here, but I know it's between 0 and 10. That's what I set the things at, so I'm just going to type them in instead. I don't like playing that game with the arrows. So type in 0 for my left bound, 10 for my right bound, and then it asks me guess. Let's hit enter one more time, and it looks like it crosses right at 6. So this one you could have done. You could have factored that or used quadratic formula, whatever. But many times that will not be the case. Right. And then calculate the speed after falling 100 meters. So that would be like having, I'm just going to rewrite my list here. What is the speed? So that would be final velocity after falling 100 meters. Now, if it's falling 100 meters, that's a negative displacement. So be careful there. So this is my Vf squared equals Vi squared plus 2a. So this is a good tour through those different kinematics equations. So that's 400 plus 2,000. I want to mess that up, so I'll just do it on the calculator. Let me be sure. Negative 20 squared plus 2 times negative 10 times negative 100. Yep. And then I need the square root of that. Square root of that is, call that 49. Now when you take the square root of things, you've got to put that plus or minus there, right? Now, you cannot have a ball that is going plus and minus 49 meters per second at the same time. You need to choose. You need to think about the context of the problem and figure out what is the right what's the right one? What's the right direction? Well, this thing started in the down direction, and it's only accelerating more in the down direction, so this VF that we're looking for is negative. Now that's the velocity. This actually said calculate the speed. So the speed would be, speed is the absolute value of velocity. So just 49 meters per second. All right. Maybe I'll finish this page and then put 4 through 6 rather, in a second video. Well, let's try this. Rock is thrown upward with an initial speed of 15 meters per second on the Earth. Diagram. You got this ball going up. That looks too much like a force diagram. I don't want to do that. Sorry. I'm going to make that dot, and its initial velocity is 15 meters per second in the up direction. Make a list of the given quantities, acceleration, initial velocity. I think it's a good habit to force yourself to write a sign down, positive or negative. Don't know what the final velocity is. I don't know anything about displacement or time yet. What's the acceleration? It's negative 10. Calculate the rock's height after 1 second. So let's see, after 1 second I have this, looking for that, so that would be my delta y is equal to 1/2 at squared plus vit. So 1/2 a is negative 5, t squared plus vit. And that is 10 meters. Right? Calculate the time required to reach an upward speed of 3 meters per second. Got to get, if you're wondering, like, how does he just always know which equation to use? Well, if you have them sitting there, you know, it might take you a little bit longer because you're not a physics teacher. But with practice, you can get good at that. I don't know why I wrote the units in there. I don't like to write the units when I'm putting numbers into an equation because it gets a little bit too messy. So I'm going to scratch that out there. Time required, looking for that. And my initial velocity was 15. So a little bit of algebra here. Looks like my time is going to be 1.2 seconds. How about the time required to reach a downward speed of 5 meters per second? So a downward speed, that's going to be a final velocity of negative 5, which is absolutely crucial that you get that sign right. And the initial velocity is still 15 in the up direction. If you solve for this, you get time is equal to 2 seconds. And that should make sense to us because what's happening is we're starting with this velocity and having an acceleration of negative 10 meters per second means every second that goes by, we're going to subtract 10. So you subtract 10, you get to 5. Subtract 10 again, you get to negative 5. Which is what we were looking for. All right. Ball punted vertically has a hang time of 3.8 seconds. What was its initial velocity? So ball is going to go up, come back down again. I'll tell you what the trick is for this one and other problems like this. You'll get used to this, I hope. At the delta y, if you've got a ball, football in this case, being kicked, it's going up, coming back down again. What's the delta y for this ball that started here and ended here at the same height? It is 0. The hang time is 3.8 seconds. We want to know what the initial velocity is. And what equation is that? And it's this one. Again. And looks like we just need to do a little bit of algebra. You heard of it, I'm sure, algebra. Add this to the other side. 5 times 3.8 squared, and then divide by the 3.8. So that ball was kicked with an initial velocity of 19 meters per second. That takes you through the first three, and that's all.